Bismillahirrahmanirrahim. Welcome to Al Munir High School e-learning system, class 9. This is your physics lecture. Today we are going to start our unit number 9. The topic is transfer of heat. This is the title page of your physics book for class 9th. Yes, we are going to start with unit number 9. The topic is transfer of heat. In this chapter I will tell you about different ways through which heat is transferred from one body to another body. So students, we already know that heat is an important form of energy and it is necessary for our survival. We need it to cook our food and to maintain our body temperature. Heat is also needed in various industrial processes. How to protect ourselves from high as well as low temperature needs knowledge of how heat travels. So in this unit we are going to study about the transfer of heat, that how heat travels from one body to another. So there are three processes through which heat transfer from into the air or from one body to another. One is conduction, other one is convection, and third one is radiation. So these are the three ways of heat transfer. Recall what happens when two bodies at different temperature are in thermal contact. As I told you in your previous unit, thermal energy from a hot body flows to a cold body in the form of heat, and this is called the transfer of heat. Transfer of heat is a natural process. It continues all the time as long as the bodies in thermal contact are at different temperature. So there are three ways by which transfer of heat takes place. First one is the conduction. What is conduction, students? The handle of metal spoon held in hot water soon gets warm, but in case of a wooden spoon the handle does not get warm. Why it is so? Because both the materials behave differently regarding the transfer of heat. Both metals and non-metals conduct heat. Metals are generally better conductors than non-metals. In solids, atoms and molecules are packed close together. They continue to vibrate at about their mean position. What happens when one of its ends is heated? The atoms or molecules present at that end begin to vibrate more rapidly, as shown in this figure. Yes, they also collide with their neighboring atoms or molecules. In doing so, they pass some of their energy to neighboring atoms or molecules during collisions with them, with the increase in their vibrations. These atoms or molecules in turn pass on a part of the energy to their neighboring particles. In this way, some heat reaches the other parts of the solids. This is a very slow process and very small transfer of heat takes place from hot to cold parts in solids. So students, in this paragraph he is telling you about the conduction process, that how conduction takes place. So we can define conduction as the mode of transfer of heat by vibrating atoms and free electrons in solids from hot to cold parts of a body is called conduction of heat. All metals are good conductors of heat. The substances through which heat does not conduct easily are called the bad conductors or insulators. Examples are wood, cork, cotton, wool, glass, rubber. All these are the insulators or bad conductors. Now the question arises, what is thermal conductivity? So here we have the definition. The amount of heat that flows in unit time is called the rate of flow of heat. So the formula is rate of flow of heat is Q over T. It is observed that the rate at which heat flows through a solid object depends upon various factors. And what are the factors? First factor is cross-sectional area. It means larger cross-sectional area of a solid contains larger number of molecules and free electrons. Other one is the length of the solid. Larger is the length between the hot and cold ends of the solid, more time it will take to conduct heat. And the third one factor is the temperature difference. Greater is the temperature difference between hot and cold phases of the solid, greater will be the rate of flow of heat. So we know that Q over T, which is rate of flow of heat, is directly proportional to difference in the temperature. When we combine all these factors, above factors, we will get this equation. Rate of flow of heat is equal to Ka. A is cross sectional area, T1 minus T2 is the difference between the temperatures, and L shows the length. Here K is the proportionality constant called the thermal conductivity of the solid. So we can define it as the rate of flow of heat across the opposite faces of a meter cube of a substance maintained at a temperature difference of 1 Kelvin is called thermal conductivity of that substance. So here we have the table of different substances with their thermal conductivities of common substances. What are the use of conductors and non-conductors? In our houses, good thermal insulation means lower consumption of fuel. Yes, hot water tanks are insulated by plastic or foam lagging. Wall cavities are filled with plastic, foam or wool. Ceiling of rooms is covered by insulating materials, which we call false ceiling. Double glazed window panes are used. These window panes have air between glass sheets that provides good insulation. So all these are the uses of conductors and non-conductors. Good conductors are those and are also used when quick transfer of heat is required through a body. Thus cookers, cooking plates, boilers, yes, radiators and condensers of refrigerators are made of metals such as aluminium or copper. Similarly, metal boxes are used for making ice and ice cream. Insulators or bad conductors are used in home utensils such as handles of saucepans, hot plates, spoons. They are made up of wood or plastic. Air is one of the bad conductors or best insulator. That is why cavity walls, two walls separated by an air space, and double glazed windows keep the houses warm in winter and cool in the summer. So materials which trap air, for example wool, fur, feathers, polyesters, fiberglass are bad conductors of heat. And some of the materials are used for lagging to insulate water pipes, hot water cylinders, ovens, refrigerators, walls and roof of houses. Next we have the example, students. Here area is given, length is given, the temperature difference is given. We can find out the temperature difference by subtracting the both temperatures. The value of K is given. Here we have this formula as we studied above. By putting all these values, we will get the rate of conduction of thermal energy. Next process or method of transfer of heat is the convection. What is convection? Liquids and gases are poor conductors of heat. Heat is transferred through fluids. Fluid means liquids or gases, easily by another method called convection. Look at this picture of hot balloon, students. A liquid or a gas becomes lighter, less dense as it expands on heating. Hot liquid or gas rises up above the heated area. The cooler liquid or gas from the surroundings fills the place, which in turn is heated up. In this way, all the fluid is heated up. Therefore, transfer of heat through fluids takes place by the actual movement of heated molecules from hot to cold parts of the fluid. So transfer of heat by actual movement of molecules from hot place to a cold place is known as convection. Look at this figure. This is the experiment which shows the convection. Take a beaker, look here in the picture, fill it 2/3 of it with water, heat the beaker by keeping burner below it. Yes, drop 2 or 3 crystals of potassium permanganate in water. It will be seen that colored streaks of water formed by the crystals move upward above the flame and then move downwards from sideways. So these colored streaks show the path of currents in the liquid. Why the liquid currents stop on removing the burner under the beaker? When the water at the bottom of the beaker gets hot, it expands, becomes lighter and rises up, while the cold but denser water moves downward to take its place. Next, our topic is uses of convection currents. Gases also expand on heating, thus convection currents are easily set up due to differences in the densities of air at various parts in the atmosphere. What are the uses? Convection currents set up by electric, gas or coal heaters help to warm our homes and offices. Central heating systems in buildings work on the same principle by convection. Convection currents occur on a very large scale in nature. The day-to-day temperature changes in the atmosphere result from the circulation of warm or cold air that travels across the region. What is land and sea breeze, students? Why does sea breeze blow during the day and land breeze blow in the night time? So reason is land and sea breezes are the result of convection. On a hot day, the temperature of the land increases. It is because the specific heat of land is much smaller as compared to water. Air above land gets hot and rises up. So cold air from the sea begins to move towards the land. So it is called the sea breeze. At the night, it is opposite to the above sea breeze. The land cools faster than the sea. So air above the sea is warmer, rises up, and cold air from the land begins to move towards the sea. It is called the sea breeze, land breeze. Yes, here we have the applications of land or sea breeze or convections. Yes, a glider, look here, this is a picture of a glider. As shown in this figure, looks like a small aeroplane but without engine. Glider pilots use upward movement of hot air currents due to convection of heat. These rising currents of hot air are called thermals. Gliders ride over these thermals. The upward movement of air currents in thermals help them to stay in air for a long period. Also, the application of convections are the birds stretch out their wings and circle in their thermals. The upward movement of air helps birds to climb with it. Eagles, hawks and vultures are expert thermal climbers. After getting a free lift, birds are able to fly for hours without flapping their wings. They glide from one thermal to another and thus travel through large distances, hardly need to flap their wings. Next our method of transfer of heat is radiation. What is radiation? Yes, students, we know that sun is the major source of heat energy. It reaches us neither by conduction nor by convection, but it reaches us on the Earth's atmosphere by radiations, by which heat travels from one place to another. So here we have the definition in this pink box. Radiation is the mode of transfer of heat from one place to another in the form of waves called electromagnetic waves. So how does this heat reach us directly from a fireplace? Heat does not reach us by conduction through air from a fireplace because air is a poor conductor of heat. Heat does not reach us by convection as well because the air getting heat from the fireplace does not move in all directions. Hot air moves upward from the fireplace. Heat from the fireplace reaches us directly by a different process in the form of waves called radiation. Radiations are emitted by all bodies. The rate at which radiations are emitted depends upon various factors like color and texture, surface temperature, surface area. Then why does a cup of hot tea becomes cold after some time? All the objects laying inside a room, including the wall, roof and floor of the room, are radiating heat. They are also observing the heat at the same time. When the temperature of an object is higher than its surroundings, then it is radiating more heat than it is observing. So as a result, heat temperature goes on decreasing till it becomes equal to its surrounding. When the temperature of an object is lower than its surroundings, when it is radiating less heat than it is observing, as a result its temperature goes on increasing till it becomes equal to its surroundings. The rate at which various surfaces emit heat depends upon the nature of the surface. Next our topic is about emission and absorption of radiation. Yes, A Selai cube is a metal box having faces of different nature. Look here in this figure, we have the radiations from Leslie's cube, a shining silvered surface, dull black surface, white surface, and a color surface. It has a different types of surfaces. So hot water is filled in that cube and is placed with one of its face towards a radiation detector. It is found that black dull surface is good emitter of heat. The rate at which various surfaces absorb heat also depends upon the nature of those surfaces. For example, take two surfaces, one is dull black and other is a silver polished surface with a candle at the middle of the surface. It is found that a dull black surface is good observer of heat as its temperature rises rapidly. A polished surface is poor observer of heat as its temperature rises very slowly. So this table shows the different surfaces, their emitter, observer and reflector. It is also found that the transfer of heat by radiation is also affected by the surface area of the body emitting or observing heat. Larger is the area, greater will be the transfer of heat. Greenhouse effect. Yes students, we already know about the greenhouse effect. Light from the sun contains thermal radiations of long wavelengths as well as light and ultraviolet radiations of short wavelengths. Glass and transparent polythene sheets allow radiations of short wavelength to pass through easily but not long wavelengths of thermal radiations. A greenhouse becomes a heat trap. Radiations from the sun pass easily through glass and warms up the objects in a greenhouse. These objects and plants such as do not allow them to escape out easily and are reflected back in the greenhouse. This maintains the inside temperature of the greenhouse. Carbon dioxide and water also behave in a similar way to radiations as glass or polythene. Earth's atmosphere contains carbon dioxide and water vapors. It causes greenhouse effect as shown in figure 9.18. So this figure shows the greenhouse effect. What are the application and consequences of radiations? Different objects observe different amounts of heat. Radiations falling upon them, reflecting the remaining part. The amount of heat observed by a body depends upon the color and nature of its surface. A black and rough surface observes more heat than a white or polished surface. Since good observers are also good radiators of heat, a black colored body gets hot quickly, observing heat reaching it during a sunny day, and also cools down quickly by giving out its heat to its surroundings. Like light rays, heat radiations also obey the laws of reflection. The amount of heat reflected from an object depends upon its color and nature of the surface. White surfaces reflect more than colored or black surfaces. Similarly, polished surfaces are good reflectors than rough surfaces, and reflection of heat radiations is greater from polished surfaces. We wear white or light colored clothes in summer which reflect most of the heat radiation reaching us during the hot day. We polish the interior of the cooking and hot pots for reflecting back most of the heat radiation within them. So students, this is all for today. Thank you. Allah Hafiz.